Hey everyone, welcome back to the channel. Today we are diving into control testing for logging and monitoring, specifically security information and event management or SIEM across two environments, Azure Active Directory with Sentinel and an on-premises SIEM setup. If you work in audit, GRC or security compliance, this walkthrough will show you exactly how to test this control end-to-end using real workpaper structure. Let's get into it. First things first, before you test anything, you need to know why you're testing it. This matters maps, logging and monitoring requirements across 6 major frameworks. Notice how each framework points back to the same core idea. Events need to be logged, monitored and reviewed. Mapping these frameworks together upfront means you're not duplicating testing effort every time a new standard comes into scope. One test, multiple frameworks satisfied. Workpaper anatomy. Every control work paper you build should follow the same structure, and here's the 9-part anatomy we'll use throughout this series. The control objective, the control steps for both design and operating effectiveness, your sampling strategy, at least 5 samples, evidence required, a step-by-step testing procedure, design and operating effectiveness checkpoints, 8 each, your results comparing expected versus actual, and finally your conclusion and recommendation. Keep this structure consistent and your work papers stay audit ready every single time. Step-by-step execution. Here's the methodology end-to-end in 8 steps. We start with planning, defining scope across Azure Sentinel and the on-prem SIEM. Then evidence collection, pulling log retention policies, dashboards and NTP configs. Testing techniques covers inquiry, observation, inspection and reperformance. Sampling means pulling at least 5 events. Think privileged logins, failed logins, system changes, alerts and terminated accounts. Then we run through our checkpoints, document everything, capture our findings using condition criteria, cause and consequence, and wrap up with a conclusion that ties back to the frameworks. Control objective. So what's the actual objective here? Simple. Ensure logs are collected, protected, monitored, and reviewed to detect and respond to security events. 4 words. Collected, protected, monitored, reviewed. That's your North Star for every test you run in this work paper. Design effectiveness checkpoints. Let's talk design effectiveness. This is about whether the control is designed properly on paper before we even test if it's working. 8 checkpoints. Is the same architecture documented? Is there a log retention policy? Are privileged activity logging requirements written down? Are alerting thresholds defined? Does an NTP sync design exist? Are log integrity controls defined? Is monitoring coverage documented across servers, endpoints, and cloud? And finally, is there a defined log review process? If any of these are missing, that's a design gap. Operating effectiveness checkpoints. Now we flip to operating effectiveness. Is the control actually working in practice? Are logs being collected centrally in the SIEM? Does retention meet policy, say 90 days online and a year in archive? Is privileged activity actually being logged? Are alerts triggering for critical events? Is NTP sync active? Are logs protected from tampering? Are logs present across endpoint servers and clouds? And are log reviews actually being performed and documented? This is where you catch controls that look good on paper but fail in reality. Evidence collection, Azure AD or Sentinel. Let's get hands-on with the cloud environment. In Azure Sentinel, you'll navigate to the logs, then security alerts, and export log events for the last 24 hours. From there, capture 2 key pieces of evidence, a screenshot of the alert dashboard broken down by high, medium, and low severity. You can see here 7 high, 14 medium, and 23 low severity alerts, and a screenshot of your KQL or custom query language, query output showing timestamps, alert names, severity, and status. Azure Sentinel centralizes identity, sign-in, and audit logins, which gives you near real-time alerting on privileged and anomalous activity. This is exactly the kind of evidence an auditor expects to see attached to the work paper. Evidence collection on-premises SIEM. Now the on-prem side, whether you're running Splunk, QRadar or ELK, the process is similar. Open the SIEM dashboard, export logs for privileged login attempts, and capture 2 screenshots. Fail login alerts showing account source, IP and time, and the privileged activity log showing which users took which actions and whether they were logged. Then grab a screenshot of your NTP sync configuration. This matters because if your time sources aren't synced, your log timestamps can't be trusted for correlation. Splunk, QRadar, and ELK all aggregate on-prem server, network, and endpoint logs, supporting the same 8 design and operating checkpoints we just covered. Test execution samples. Time to actually execute the test. We are using a sample size of 5. Privileged login, failed login, system change, network alert, and terminated account. The steps are straightforward. Inspect the SIEM logs for each sampled event. Verify timestamps are consistent thanks to NTP sync. Check that alerts triggered for critical events and review log integrity protection. In our example here, we expected all 5 sampled events to be logged with alerts triggering correctly and retention meeting policy. What we actually found, one terminated account login wasn't logged. That's 1 out of 5 sample exceptions, and that exception is what drives our finding. Workpaper example, finding detail. Let's turn that exception into a proper finding. The condition, one privileged login wasn't captured. The criteria, PCI DSS requirement 10 requires all access to be logged. The cause, SIEM agent was misconfigured. The consequence, risk of undirected admin activity. And the recommendation, fix the agent configuration and retest. Based on this, the control is rated